Okay. First, we take all the outcomes from set A and which are new one. We have to select in B which are new one. HTH already it is in A. Need not to write there. Repeated it is. THH this also repeated. Then only new one is HHH. Hence, 4 outcomes belongs to the A union of B. Yes, what is the A union of B set belong B? That is equals to HHT, HTH, THH, HHH. We have to find the probability for all individual outcomes. Therefore, P means probability of A union B. Probability of A union B equals to probability of first outcome plus probability of second outcome plus probability of third outcome plus probability of fourth outcome. Each individual outcome is having the value of probability of HHT is equals to 1 by 8 because how 8 comes means total number of sample spaces while coin is tossing thrice 8 sample space number is equals to A's. The number of sample spaces, total number of outcomes present in the sample space is equals to 8, 1 by 8. Each individual probability of PHHT is equals to 1 by 8. Similarly, 1 by 8 plus 1 by 8 plus 1 by 8, that's equals to 4 by 8, which gives 1 by 2. This is the equally likely outcome. Equally likely outcome. Yes, that means and also P of A is equals to probability of A is equals to, here we can find probability of HHT plus probability of THH plus probability of HTH. Yes, the probability of 3 outcomes is equals to 3 by 8. That is the first set probability. Whatever we have taken here A, here 3 outcomes are there. Their individual probability defined by P of A equals to P of HHT plus P of HTH plus P of THH. Hence the total probability equals to 3 by 8 for the set A. The total probability of P of B is equals to, then that's equals to, that is 3 by 8 for the set B. Hence, P of A plus P of B, P of A plus P of B, that is equals to 3 by 8 plus 3 by 8, which gives the 6 by 8. 6 by 8. From this, it is clear that probability of A union B, probability of A union B, which gives the value of 1 by 2, which gives the value of 1 by 2, then probability of A plus probability of B, which gives the value of 6 by 8, but these two, P of A plus P of B is not equals to probability of A union B. Probability of A union B. Am I right here? Is it clear? Once again you recall. Then continue. Means from the above expression we have clear that probability of A union B, if all the outcomes are equally likely outcomes, should not be equals to the probability of A plus probability of B. That means the points HTH and THH. Is it clear? The points HTH H, observe in the set A and set B, and T, H, H are common to both A and B. Am I right here? You observe these 2 points are common. H, T, H. Here H, T, H. This is common point in A as well as B set. T, H, H. See here, T, H, H is the common in set A and set B. Yes, both are common. In this computation of probability of A plus probability of B are probabilities of the points H, T, H and T, H, H. Is it clear here? Is it clear? In this computation of the probability of A plus probability of B are the probabilities of the points H, T, H and T, H, H. Both are common points. That is, the elements A intersection B are included twice. Wherever from the two sets suppose we get the common elements, then A intersection B we can express it here. A intersection B defines the common elements from the set A and set B. So the elements A intersection B are included twice. Thus, to get the probability of P of A union B, we have subtract the probabilities of sample points in A intersection B from the set P of A plus P of B. Am I right here? Yes, okay. Once again you recall. Okay. Then, that means what he says, suppose the elements A intersection B are included twice. Thus, to get the probabilities of P of A union B, we have to subtract those probabilities of sample points in A intersection B from these two, P of A plus P of B, from P of A plus P of B. So, then that is P of A union B equals to probability of A plus probability of B minus summation of probability of omega I, where omega I belongs to A intersection B. This is nothing but the 2 points are common points in set A and set B. Those common points are defined HTH and THH. ಅಂದ್ರೆ ಸಾಮಾನ್ಯವಾಗಿ ಏನದ ಒಂದು ಘಟನೆ ಹೊರಗೇನು ಬರ್ತದೋ ಅದು ಎರಡೂ ಸೆಟ್ನಲ್ಲಿ ಬಿಲಾಂಗ್ ಆದಂಥ ಘಟನೆ, ಎರಡೂ ಸೆಟ್ಟಿಗೆ ಸೇರಿದಂಥ ಘಟನೆ HTH ಆ್ಯಂಡ್ THH. ಇದು ಎರಡೂ ಸೆಟ್ನಲ್ಲಿದೆ. ಇವು ಎರಡೂ ಘಟನೆಗಳು ಏನು ಔಟ್ಕಮ್ಸ್ ಇದ್ದಾವೋ, ಇವು ಎರಡೂ ಔಟ್ಕಮ್ಸ್ಗಳು ಸೆಟ್ ಎನಲ್ಲಿನೂ ಇದ್ದಾವೆ, ಸೆಟ್ ಬಿ ನಲ್ಲಿನೂ ಇದ್ದಾವೆ. ಅಂಥ ಸೆಟ್ನಲ್ಲಿರ್ತಕ್ಕಂಥ ಈ ಔಟ್ಕಮ್ಸ್ಗಳು, ಎರಡೂ ಔಟ್ಕಮ್ಸ್ಗಳನ್ನು ನಾವು ಏನು ಮಾಡಬೇಕಂತ ಹೇಳ್ತಾನಂದ್ರೆ, ನಾವು ಪ್ಯೂರ್ಲಿ probability of A union B ಸಂಯೋಗ ಗಣ A ಸಂಯೋಗ B ಗಣದ ಮೌಲ್ಯವನ್ನು ನಾವು ಅದನ್ನು ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಪ್ರತ್ಯೇಕವಾಗಿರ್ತಕ್ಕಂಥ ಒಂದು ಸಂಭವನೀಯತೆ A ಮತ್ತು ಪ್ರತ್ಯೇಕವಾಗಿರ್ತಕ್ಕಂಥ ಸಂಭವನೀಯತೆ B ಘಟನೆಗಳಲ್ಲಿ ಅವು ಎರಡೂಗಳನ್ನು ನಾವು ಏನು ಮಾಡಬೇಕಂತ ನಾವು ಮೈನಸ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತಾನೆ. ದೇರ್ಫೋರ್ P of A union B is equals to P of A plus P of B minus P intersection B. ಸರ್, ಇದು ಎಲ್ಲಿದು ಬಂತಂತ ನಾವು ಕೇಳಬಹುದು. ಇಲ್ಲಿವರೆಗೆ ಮೇಲಿನ ಒಂದು ಪ್ಯಾರಾಗ್ರಾಫ್ನಲ್ಲಿ ನಾ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೆ. P of A ಇಂಟರ್ಸೆಕ್ಷನ್ B ಅಂದರೆ A ಛೇದನ B ಗಣದ ಮೌಲ್ಯಾಧಾರಿತ ಎರಡು ಔಟ್ಕಮ್ಸ್ಗಳು HTH THHಗಳು ಏನರಿಗೂ ಸೇರಿದೆ, ಬಿ ಗಣದಲ್ಲಿನೂ ಸೇರಿರುವುದರಿಂದ ಇವು ಎರಡೂ ಗಣಗಳನ್ನು ನಾವು ನಿಶ್ಚಿತಪೂರ್ವಕವಾಗಿ ಇವುಗಳನ್ನು ನಾವು ಏನು ಮಾಡಬೇಕಂತ ಹೇಳ್ತಾನೆ, ಇವುಗಳನ್ನು ನಾವು ಪಿ ಆಫ್ ಎ ಪ್ಲಸ್ ಪಿ ಆಫ್ ಬಿ ನಲ್ಲಿ ಮೈನಸ್ ಮಾಡಲೇಬೇಕು. ಎಸ್, ದೇರ್ ಫೋರ್ ಪಿ ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಪಿ ಆಫ್ ಎ ಪ್ಲಸ್ ಪಿ ಆಫ್ ಬಿ minus P intersection B. That means this implies what produce the value. This implies A minus B union of A intersection B union of B intersection A ಅಂತ ಇದು ತೋರಿಸ್ಕೊಡ್ತದ. ಎಸ್, ಇಲ್ಲಿ ಮುಂದೆ ಹೇಳ್ತಾನೆ ಈಗಿದು. This implies A minus B union A intersection B union B minus A. Yes, am I right here? Then A union B equals to A union B is equals to A union B equals to A union B minus A. A union B minus A, where A and B minus A are mutually exclusive events. Am I right here? Is it understand? Here these events A union of B, the value of probability of A union of B, if all the outcomes are equally likely outcomes. But here A union of B is equals to A union of B minus A, where A and B minus A and B minus A are mutually exclusive events. ಇದರ ಬಗ್ಗೆ ನಿಮಗೆ ಹಿಂದೆ ನಾನು ಸಾಕಷ್ಟು ವಿವರಣೆ ಕೊಟ್ಟಿದ್ದೇನೆ. ಮ್ಯೂಚುವಲಿ ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಇವೆಂಟ್ ಎದಕ್ಕಂತಾರೆ ಎಂಬುದನ್ನು. ದೆನ್ B is equals to A intersection B union B minus A. A intersection B minus A. ಇದು A ಯೂನಿಯನ್ B, ಇದರಲ್ಲಿ A ಮತ್ತು B ಮೈನಸ್ ಎಗಳು ಮ್ಯೂಚುವಲಿ ಎಕ್ಸ್ಕ್ಲೂಸಿವ್. ಆದರೆ ಓನ್ಲಿ ದ ಸೆಟ್ B ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು A ಇಂಟರ್ಸೆಕ್ಷನ್ B ಯೂನಿಯನ್ B ಮೈನಸ್ A. ಇದು A ಇಂಟರ್ಸೆಕ್ಷನ್ B and B minus A, where A intersection B and B minus A are mutually exclusive event. Because in the axioms of the third rule, in the third law, in the axiom of the third, by using the axiom third of the probability, ಮೂರನೇ ನಿಯಮವನ್ನು ನಾನು ಹೇಳಿದ್ದೆ. axiomatic approach of probabilityಯಲ್ಲಿ ಮೂರನೇ ನಿಯಮದ ಪ್ರಕಾರ ನಾವು ಏನದ ಪಿ ಆಫ್ ಈ ಎರಡೂ ಇವುಗಳನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಪಿ ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು P of A plus P of B minus A, P of A plus P of B minus A, which gives the equation 1. ನಾವು ಈ ಎರಡೂ ಮ್ಯೂಚುವಲಿ ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಇವೆಂಟ್ಗಳನ್ನು ಪರಿಗಣಿಸಿದಾಗ ನಮಗೇನಿದೆ, ಮೂರನೇ ನಿಯಮವನ್ನು ಅನ್ವಯಿಸಿದಾಗ ಎ ಯೂನಿಯನ್ ಬಿ, ಎ ಸಂಯೋಗ ಬಿ ಗಣದ ಸಂಭವನೀಯತೆ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು P of A plus P of B minus A. Am I right here? Okay. Right? Then next, P of B equals to, then next is P of B equals to P of A intersection B plus P of B minus A. Already we found here P of A union B equals to P of A plus P of B minus A, and P of B equals to P of A intersection B plus P of B minus A. Then by subtracting this, you consider as the second equation, this as the second equation, which one earlier is the first equation. Subtracting second equation from the first equation, which gives, we get P of A union B minus P of B. ಒಂದನೇ ಇಕ್ವೇಷನ್ದಲ್ಲಿ ಲೆಫ್ಟ್ ಸೈಡ್ P ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ ಮೈನಸ್ ಎರಡನೇ ಇಕ್ವೇಷನ್ದಲ್ಲಿ ಲೆಫ್ಟ್ ಸೈಡ್ ವ್ಯಾಲ್ಯೂ P ಆಫ್ ಬಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು, ಅವನ್ನೆರಡೂ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ P ಆಫ್ ಎ ಮೈನಸ್ P ಆಫ್ ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿ. ಅಲ್ಲಿ ಪಿ ಆಫ್ ಬಿ ಮೈನಸ್ ಎ ಅಲ್ಲಿ ಕಾಮನ್ ಇತ್ತು, ಇಲ್ಲಿಯೂ ಕಾಮನ್ ಅದ, ಎರಡೂ ಎಲಿಮಿನೇಟ್ ಆಯ್ತು. ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡಿದಾಗ ಇದು ಒಂದು ಸೈನ್ ಮೈನಸ್ ಬರ್ತದೆ, ಒಂದು ಮೊದಲು ಪ್ಲಸ್ ಇರ್ತದೆ, ಪ್ಲಸ್ ಮೈನಸ್ ಗಾನ್, ಓನ್ಲಿ ಪಿ ಆಫ್ ಎ ಅಲ್ಲಿ ಉಳಿತು, ಮೈನಸ್ ಎರಡನೇದ್ರಲ್ಲಿ ಇಕ್ವೇಷನ್ದಲ್ಲಿ ಪಿ ಆಫ್ ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿ ಉಳಿತು. ಹೆನ್ಸ್ ಪಿ ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ಪಿ ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ minus P of B is equals to P of A minus P of A intersection B, or P of A union B equals to probability of A plus probability of B minus probability of A intersection B. ಈ ಒಂದು ಇಕ್ವೇಷನನ್ನು ನೀವು ಬಹಳಷ್ಟು ನೀವು ವಿಚಾರ ಮಾಡಿ ಗಮನಿಸಿ ನೋಡಿದಾಗ ವೆನ್ ಡೈಗ್ರಾಮ್ದಲ್ಲಿ ಎನ್ ಆಫ್ ಎ ಯೂನಿಯನ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ಎನ್ ಆಫ್ ಎ ಪ್ಲಸ್ ಎನ್ ಆಫ್ ಬಿ ಮೈನಸ್ ಎನ್ ಆಫ್ ಎ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬಿ ಅಂಥೇಳಿ ನೀವು ಇದನ್ನು ನೆನಪು ಮಾಡ್ಕೊತೀರಿ. 8ನೇ ತರಗತಿಯಲ್ಲಿ 9ನೇ ತರಗತಿಯಲ್ಲಿ ವೆನ್ ನಕ್ಷೆಯನ್ನು ನಾವು ಇದನ್ನು ಬಿಡಿಸುವಾಗ, ವೆನ್ ಡೈಗ್ರಾಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನು ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಇದೇ ಫಾರ್ಮುಲಾ ನಾವು ಅಲ್ಲಿ ಎನ್ ಈಸ್ ಆ್ಯಸ್ ಎ ನ್ಯಾಚುರಲ್ ನಂಬರ್, n belongs to the set of natural number. But here we have find the probability of A union B, probability of A plus probability of B minus probability of A intersection B ಅಂತ ನಾವು ಇಲ್ಲಿ ಪ್ರೂವ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಎಕ್ಸಿಯೋಮೆಟಿಕ್ ಅಪ್ರೋಚ್ ಆಫ್ ಪ್ರೊಬೆಬಿಲಿಟಿಯಲ್ಲಿ ಈಗಾಗಲೇ ನಾವು ಇದನ್ನು 3ನೇ ಒಂದು ಪಾಯಿಂಟನ್ನು ಅಭ್ಯಾಸ ಮಾಡಲಿಕ್ಕತ್ತಿದ್ದೀವಿ. ಮೊದಲೇ ಪಾಯಿಂಟ್ ಇತ್ತು ನಮಗೆ, ಅದು ಈಗಾಗಲೇ ಆ ಮೊದಲೇ ಪಾಯಿಂಟ್ ನಾವು ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ, ಅಲ್ಲಿ ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎನ್ ಇವೆಂಟ್. 2ನೇ ಪಾಯಿಂಟ್ ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ, ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಈಕ್ವಲಿ ಲೈಕ್ಲಿ ಔಟ್ಕಮ್ಸನ್ನು ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ. ಈಗ ಇಲ್ಲಿ 3ನೇ ಪಾಯಿಂಟನ್ನು ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀವಿ, ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎ ಆರ್ ಬಿ ಅನ್ನು. ಎಸ್, ದಿಸ್ ಈಸ್ ದ last point. Then in the next class we shall be study about the last point, which is known to be as the probability of event not A. Probability of event not A. Adre one question may I wish to ask a question. Dear students, you know, in the third point of the axiomatic approach of the probability, axiomatic approach to the probability, that is the probability of the event A or B is equals to A probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. Can you represent this expression in Venn diagram? Is it possible to represent the probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B in the Venn diagram? Yes, it is possible to represent the Venn diagram. In the next class, we shall be study with this representation through the Venn diagram, through the figure. Then last one is probability of the event not A. This is the last theoretical concept, theoretical part in this probability chapter. After this completion, then we shall be solve some questions. We'll solve some questions with exercise 16.3 with worked examples also. Then the chapter will be over. Good evening, students. Now we shall continue the probability, that is axiomatic approach of probability. In the last class we have studied the axiomatic approach of probability introductory part, definition of probability in the axiomatic concept. Thereafter, some examples for the axiomatic approach of probability with assignments which are valid. Then the first one is probability of an event. Second one is probability of equally likely outcomes. We have derived the two important concepts from the axiomatic approach of probability. And the next third concept in the axiomatic approach of probability, that is probability of the event A or B. What is that? Probability of the event A or B. In the earlier classes, we know the probability of event A or B, A and B, the event A but not B. Like this we have studied all together types, but in this concept, this is very important role, the probability of the event A or B. Let us find the probability of event A or B, that is A union B. A or B means A union B. A union B ಅಂದರೆ A ಸಂಯೋಗ B. A ಮತ್ತು Bಗಳು ಎರಡು ಶೂನ್ಯ ರಹಿತ ಗಣಗಳಾಗಿರಲಿ. ಎಯು ಬಿದೊಂದಿಗೆ ಸಂಯೋಗ ಹೊಂದಿದಾಗ ಬರುವಂಥ ಒಂದು ಹೊಸ ವಿಶೇಷ ಗಣವನ್ನು ನಾವು ಎ ಯೂನಿಯನ್ ಬಿ ಅಂತ ಕರಿತೀವಿ. ಹೌದು, ಗಣಗಳಲ್ಲಿ ನೀವು ಪ್ರಕಾರಗಳನ್ನು ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೀರಿ ಈ ಹಿಂದಿನ ತರಗತಿಗಳಲ್ಲಿ, 9 ಮತ್ತು 10ನೇ ತರಗತಿಗಳಲ್ಲಿ. ಆದರೆ ಇಲ್ಲಿ ಎಲ್ಲ ಪ್ರಕಾರಗಳನ್ನು ಕೂಡ ಏನದ ಕೆಲವೊಂದು ವಿಶಿಷ್ಟವಾದಂಥ ನಿಯಮದೊಂದಿಗೆ ಅವುಗಳನ್ನು ಸಂಯೋಜನೆಗೊಳಿಸಿದ್ದಾನೆ. ಬಟ್ the probability of the event A or B is nothing but A union B. Let consider A is the set of outcomes. A is equals to H H T, H T H, T H H. Yes? A coin is tossed thrice, 3 times. At a glance, while tossing the coin, we have to find the 3 outcomes. Anyhow, it may be H or it may be tail. But here, let A is the defines a set consisting 2 heads appears. 2 heads appears here. Let A is the set of outcomes, that is HHT, means 2 heads are there, 1 tail is there, while a coin is tossing thrice. While a coin is tossing a thrice. Here HTH. Then third time THH. In all these 3 outcomes, 2 heads are appears. 2 heads are appear. Here 2 heads, here 2 heads, here also 2 heads. While tossing a coin thrice, the number of the sample spaces is equals to 8. Number of sample spaces is equals to 8. But here, for in this example, to assign the A or B probability of the event, A union B of the event, then the 2 events associated with tossing a coin thrice, what happens here, we can see further, right? No. B is the one of the set. 2 heads appears. Here also 2 heads appears. H, T, H, T, H, 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 H. Means here the set A and set B, comparing these, here 2 heads appears, here at least 2 head appears. Yes? HTH, THH, HHH. Be the two events associated with tossing a coin thrice. What happens here? Set A, set B. We can form A union of B. A is associated with B. That's equals to A union of B equals to HHT, HHT, HTH, HTH, THH. Whatever the outcomes belongs to set A, first we should write in this set.